All right. I'll start with the weird ones. So this one, Vx0. So what is that? You can just blurt it out. Initial velocity. I don't know why I have to put this off. So this is initial velocity, and you could call it starting velocity. I like initial velocity. And how about x? I'm going in weird order here. This is kind of a weird one. Well, what does x symbolize? No, it's not displacement. That would be delta x. So delta x is displacement. So x marks the spot. Yeah, sort of. So what is x? One word, position. And it looks like there are a couple of kinds of x's up here. There's x. There's x, and then there's x0. So I think we're going to want to change that. So we'll take 0. Initial position. So if x0 is initial position, then what should we really call x? Final position. Sorry, I should have written final position, but I don't want to rewrite it. So it's final position. And then displacement, if you want to find the displacement, or if you want to find any kind of a delta is change. And if you want to find the change in anything, what's the mathematical way to go about it? Like change in Mr. Stapleton, change in the desk, subtract what minus what? Final minus initial. Final minus initial. And it's important to do that because the last problem on the test, there was something that was, one of these was positive or one of these was negative, and you ended up, if you did it right, you were subtracting a negative, so the change was positive. But a lot of people just saw two numbers, and they took the positive one and subtracted the negative one. They were doing initial minus final, and they got the wrong answer. So this is just taking the change is definitely going to give you some kind of an answer whose sign is important. If the change ends up being positive, we know we're adding to something. If the change is negative, we're subtracting. And if the final thing is to the right and the initial is to the left, we're going to get a positive change. But if the final is over there and the initial is over here, and you subtract that minus this, and you get a negative number. So how about Vx? What's that? Final velocity. And one thing that really wasn't on there was delta x, the displacement, and delta v really wasn't on there. You could solve for delta v if you have this and that, but there's no formula on there that says delta v equals vx minus v0, and you just had to know that. So the formulas are here, the big ones, but there are also some other ones that just aren't on the list that you've got to know. How about, what's the difference between A and A with the line over it? What do you think?
Is the line over it average velocity?
Yeah, and just like delta t and t, they're really the same. They all mean average velocity here. Sorry, not average velocity, it's average acceleration. So these are really the same. This is not just the instantaneous acceleration at some moment. This is talking about how much something moves, that's displacement, given an initial velocity over a certain time, and then that depends on how fast the thing is accelerating over the whole time period. So this, even though it doesn't have the line, it really is average acceleration. And this is average acceleration. And since these are constant acceleration formulas, the average and the exact acceleration at any moment, they're going to be the same anyway. If the acceleration doesn't change, then it's always going its average acceleration. And then there's like I was just mentioning, there's T and there's delta T. So in these formulas, is there any difference? Which one's really correct? Which one should all the formulas say delta T, or should they all say T?
Delta T, right?
Delta T. I don't think there are any, I guess, assuming that time starts at 0 on all these, then maybe T is okay. But really, they can all say delta T, and that would be fine. So delta T is just change in time. It's I'm going to call it time elapsed, and it's always going to be a positive, and that's what the T means. That's kind of confusing. I think we've covered most of them. So make sure that you know what all those are. Otherwise, especially if you don't have a good handle on what the formulas do, you won't really be able to apply them well.